Hello, folks. This is Advent of Code day number 15, and I'm really excited for it. We've got about 5 minutes before it starts, so let's go ahead and have a look at what we've done so far and where we have to go. So far, the story is we started on the top of the ocean, and the sleigh keys got dropped into the water, which is a little unfortunate. But we managed to have a submarine, which was handy, and it was covered in Christmas lights. And we basically were traversing down to this bottom of the seafloor to go in pursuit of the sleigh keys. All right, so let's go ahead and make a template file. And let's go ahead and make an input file. And let's update all of these things the standard way. I know I don't generally tend to use OTel attributes right off the bat. Yesterday was kind of a recap of the same strategy that you could have used on the lanternfish puzzle. So basically, instead of tracking exactly simulating each thing, I just simulate the one representative per category, and then you track how many for each category, what does it turn into. Sounds kind of exciting and fun. Okay, so we have something like this. That looks basically like the structure that we use to start off every puzzle in this year, at least. Cool. All right. How are folks today? Yeah, the lighting is back to normal. I end-jiggered my my camera, so see what impact it has on the frame rate that turns up on YouTube for my camera. But it was a slideshow the past couple of days, but hopefully it's better now. Right, we've got 2 minutes until the puzzle unlock, and we're just going to go through it. And after that, I need some rest, definitely, because it's been pretty tiring. Right now, my company is doing a big marketing event, which means kind of emceeing a big virtual event and being live on screen for like 3 hours a day, and that is a lot, in addition to also doing Advent of Code. But that is all right. That is all right. Great. Let's go ahead and have a look over here. Yeah. Well, we'll see how difficult today is. Good luck, Viwu. The chess thing you were streaming yesterday seemed interesting, but on the other hand, I was really tired, so I had to leave. But I hope that it was enjoyable for you and your audience, Viwu. Cool. Well, seeing no other questions, let's just go ahead and get this show on the road then. Got about a minute until puzzle unlock, and then we'll see what the puzzle is, and then we'll do it, and then we'll go to bed. That is the plan. Looks like my friend Irene's is also streaming, so, we'll see which one of us finishes first. Okie doke. Yeah, if you want to see more of my work stuff, go ahead and sign up for Honey Dev Week. If you go to just honeycomb.io and just go to the top, there's a big giant banner for how to join Honeycomb Dev Week. It's really eye-catching too, because it's got the nice little colors and shapes and other kind of things that you might want to differentiate and understand. All right, 30 seconds to go. 30 seconds, 30 seconds. Also, I've got a snazzy little mug. Mark sent it to me. We go. Oh, it's another risk level puzzle. path with the lowest total risk. Oh, okay, this is just literally going to, okay, yep, that's straightforward. Can I do diagonals? I am, the risk level of the position that you enter, leaving your initial position doesn't induce risk. Okay, cool. Great. A-star search. So we're just gonna do an A-star search. Okay. Strconv. Actually, wait. No, I don't need strconv to do this. Okay. So type. Yeah, we'll do it this way. That way, it just enumerates the directions I can go. That way, I don't need to do any special logic. And it would technically be faster. You know what? I don't care enough. Okay. Okay. So now. This is row, this is column, this is going to be the risk. Whoa, my cell phone is making this go off. Okay, move my cell phone away from my mic. So, risk map. Nope, this is chord, not pair. Okay. So we start in the upper left, and our destination is the bottom right, and we cannot move diagonally. Great. Okay, that's the clarification I needed. Okay, so let's go ahead and set up some standard functions here. So we're going to have something like this. Risks. And we'll go ahead and get a list of chords. Okay. Just something standard like this will do. If and we also need a star heuristic. Okay. Gotta remember how to do an A star. It's been a little while. Oh, right, okay. We do it this way. R delta 1 or no, it's just easier to literally enumerate them. Okay. Up. Yeah, I'm going to be lazy. Down. Left and right. There we go. Okay. Actually, this logic, again, can be simplified just into up, down, left, right. Okay, that'll do it. Okay, so now it never makes sense to backtrack. So we're just going to keep a path, which is going to be a chord array. Okay. So here, let's go ahead and do a depth first search. That seems like the right thing to do. Okay. All right, that should do it. So basically, we're going to explore preferring to go down or to the right where possible. In fact, yeah, I don't really need the A star aspect because they're just the heuristic is just always go down or right where you can. Okay. So all right. Okay, so we just need our final position that we're aiming for. All right, so that should do it. So we're just going to do it this way. Computing lowest value found so far along this path. All right. So we need to avoid double visiting things. So a path, in addition to having a chord, will have a visit, and then we'll have a sum. Okay. Okay, so now we're going to explore each of the children. Oh, and I didn't actually do my parsing. That's hilarious. So this is actually int of risk minus 0. Okay. So all right, so that should work. The other interesting property that I'm thinking about is that this puzzle is symmetric. You can start from the end and work your way backwards as well. But let's not worry about that too much. So okay, and I don't want, nah, whatever, this is not going to be a deal. Something like that should do the trick. All right, so how do we do this? We know essentially that the lowest possible set of values is going to be, if it were just literally 1, 1, 1, 1, 1, 1, 1. Let's see, A star decimal optimal. I'm trying to remember, is it the A star? Best first, blah, 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 blah. H is the heuristic, the cheapest path. Yeah, okay. Okay, yep, so okay, so the cheapest possible value would be if everything cost 1. So let's go ahead and do that. So if everything cost 1, then I just literally have to do dist c minus c plus dist r minus cr. Okay. Great. Okay. And here we need the risk, and this is actually going to return not just a list of chords, but actually it's going to return a list of scores, I think. Okay, this is doable. I'm just a little bit rusty with my graph searches. We don't really do graph searches that much at Honeycomb. We do a lot of kind of low-level storage banging, but okay. Okay, so want the path. The path's sum. You know what? We'll handle it this way. Rather do it this way. Okay. So something like this should do the trick, and return chords costs. Okay. So now, path cost plus costs I plus n heuristic. Okay. So now we visit them in heuristic order. So now we create a bunch of candidate costs almost. How do I encode this? May as well just add another int. It's fine. This is fine. This is fine. This is fine. Okay. Okay. So go through this in order of least to greatest cost. How do we handle this? Each iteration of its main loop, it needs to determine which path to extend. It does so based off of the cost of the path and an estimate of how long to extend. Use a priority queue. Okay, so this is not actually a... Okay, so we do use a priority queue, and this is actually not recursive. Swear I remember how to do this. Once upon a time, I knew how to do this, and then it got rusty because I don't think we did an A-star last year. Maybe one of our friendly folks listening remembers whether there was a one last year. So maybe length of the shortest path. Never overestimates. Yep, guaranteed to return a least cost. Okay. Right. So we start with the open set. Oh, right. Okay. Yeah. We don't actually need to store the paths. That was the that was the thing. Okay. So let's change this because now I vaguely remember how to do this. Okay. Yes, I basically had this right. I just had some things slightly wrong. All the people who have pre-written A stars. Yeah, so basically we took last year off of pathfinding, which is why I don't at all remember how to do this, but that's okay. Okay, so let's take a risk map. Okay, so this looks a lot cleaner, and then we're going to do okay, that seems fine. Yep, that looks okay. Where is start used? Okay. All right. So we do it essentially this way. So the work list starts off as a so we do need a work element has position, chord, and a priority int. What's the difference between a G score and an F score? Okay. So what's the F score? Oh, F score is just the G score plus the heuristic. Okay, that's fine. And this is just going to have one element in it, which is a work element with I got this. It's fine. Yeah, I re-implement every year from scratch, mainly because it's kind of a learning exercise to keep my skills fresh. Okay. All right. Right. And that also has a score of, it starts, the G score is just going to be the G-score is going to be heuristic. Okay. That helps me construct that. All right, and okay, so something like that should work. All right. So, yep. So we've got our scores, which are these, the known risk map, and we've already defined that the risk map has a score of 0. Great. Okay. So. As long as the length of the work list is not equal to 0, current is the work list index 0. If current equals dest, then return reconstruct is just, oh, I see. Yeah, I understand. So if current is dest, then we reconstruct the path of where we came from. Okay, current is okay. Came from current, so yeah, I understand this. Okay. Right. Yeah, that'll do it. Okay, so let's set remove current. Okay. All right. Pop the current node off the work list. I'm basically rewriting this in Liz-friendly language that we actually understand. Tracing on path to start. Okay, so now, yep, so now we do this. So current dot position. Okay. For each neighbor of current, the tentative score is the... Okay, yep. Okay, so for each neighbor, yep, okay, so all that logic was fine. So we don't need the anti-backtrack anymore. Proposed score is the known value of current plus the costs of I previous value okay, known neighbor, not okay, or this value it's going to be score, not value. Then known of n gets set to proposed score the how do we approach this? Then we have a history of n equals current position. And then now we need to where is F score? Okay, so let's ignore that for now. So where is my heuristic? Oh, I see. This is the heuristic value. Okay, so this is going to be proposed score. So now so where do we use F score? Where do I use G score and Oh, I see. Okay. So we don't actually need this. Okay, I'm just going to call these the same thing, just to match what they have. It's a little bit annoying, but we'll do it that way. G score and F score is going to be make of risk of map. Okay, this is a little bit less satisfying, but that's okay. That's a-okay. Okay, so it's going to be came from and oh yeah, this is still R. That's still history. That's all good. Okay. Okay, I understand how to do this. All right, I'm learning today. Learning is important. I am relearning how to do an A-star search. So F score of so we've defined the two maps that they called for. Well, the open set is not empty. So at the end of this, sort the work. Insert into can something have a score that changes while it is still in the work list? Is there a reason they specifically asked to have a set? You know what? There must have been some reason that they did this way. We'll go ahead and do it their way. Okay. Work list is a map of chord to bool that has one entry in it, which is source is true. Okay, so now this no longer works. But this now needs a sort function. Which is linear in the time of the work list, but that's not going to be the end of the world for a problem of this size. I feel like my brain is molasses today. Okay. Okay, so let's finish up down here and then we'll come back. From the empty map. So S score neighbor, proposed score plus heuristic. If work list n, then okay. Actually, this can just abbreviate to that because this is just a set. Okay. Okay, that looks good. So history, G score, F score. Yep, that's fine. Okay, all right. Max or max int? I think it's max int. If so, we use the G score or the F score. Okay, every node that's put on the list should in theory have a F score. And this here is a G score. You know what, this is just a linear lookup. I would much rather just do it this way. So that's not going to be costs I, that's just going to be R. Okay. So we'll not bother tracking the costs. We'll just do it this way. Okay. Score is less than current score, then Hi Lala. I'm glad that you're finished. I am definitely not. Okay, let's try running this. I have no idea whether it's going to work or not, but we'll try it. It's probably going to spit out something nasty at me. Yeah, it did. There's no work element either anymore. What did I do wrong here? Oh, I just literally forgot to put commas. Okay, oh, this is just... Okay. Line 88's wrong. Oh, that's because I just failed to turn the return type here. So we'll fix that really fast. Yep, so that just returns a list of chords to iterate through. Line 88. current now. And 9. So this is not known anymore. This is just going to be G-score. 991. Again, this is just doing that. And line 93, heuristic of risk. Oh. There we go. Let's see what happens. Is it even running? Yeah, it's running. Okay, so if this is working correctly, then what we should have is, let's do this. See how deep we are. Okay, so the work list is varying from 6 to 7 elements. Am I visiting the same element over and over again? Would be the other thing. Where is F score being populated? That's being populated fine. Okay. So I probably have another bug somewhere. See what's going on here. Oh yeah, that's bad. I'm repeatedly backtracking. That's no good. So why am I repeatedly backtracking? And what's going on here? So A-star search algorithm. Neighbor of current. Okay, so but that should always increment. Value with the lowest S score value. Yeah, that's fine. I shouldn't need this, but I'm going to put it in here anyway. Let's try this now. 990. Oh, history bracket current. Okay, no, I'm still walking in circles. That's not helping me. Okay, so I have several bugs going on here. Okay, let's read through the pseudocode again. G-score gets populated to 0. S-score gets populated to the heuristic. Is my heuristic working? Let's find out. Ah! I have my... Okay. Let's try that again. Yeah, that's going to be correct because it has to go down 99 times and then it has to go to the right 99 times. That's correct. Yeah, so the heuristic is in good shape. So if there is no g-score, it's going to definitionally be lower. Or if the proposed score is lower than the g-score. Found new shortest path. Okay, so I am finding new shortest paths. And if it isn't on the work list, we put it on the work list. Oh, no, this is nested inside. That's my problem. Okay. That was my obvious silly bug. There we go. That's better now. Okay. I'm going to put this answer in. That's correct. Okay. I understand this. Okay, so this works. I just Python indentation got me. That's okay. I'm happy enough with this. Cool. So what we need to do is we need to produce a new risk map, and to repeat the exercise, I guess. So that's fine. All right. All right, so how do we do this? Essentially, I'm going to do this. So for each one, it needs to be duplicated five times. And then also do it like this. Okay. So once I got the A-star search written, it was fine. Risk levels are one higher than the tile immediately up or left of it. Great. So basically, we'll have something like this. So R plus C is the amount. And we wrap risk levels above 9, wrap back around to 1. So okay, so we're going to call this, we need to do this now. So okay, the new coordinate is going to be at KRKC plus R times width plus, oh no, height plus C times height. Okay. Plus increase. So it's always going to be from 1 to 9. So therefore, the value is going to be 1 plus v plus increase minus 1% 9. Is that correct? So I think that's correct. Try running it. That's not happy. Why is that not happy? Probably because I'm not actually populating everything. Also, where did I put my print lines? I know I've got too many print lines there. Okay, cool. Okay, yeah, my expanded risks is completely wrong. Oh, that's because this is expanded. Is that number going to be correct? Yeah, it's 25 times 10,000. Yeah, that's good. That's good. Okay. Where is the bug in my algorithm now? It's running, but it's going to take a while now. Oh, it just finished. Let's try putting that in. That's correct. Okay, problem complete. That took longer than I would have liked, but that's fine. Still got it done within an hour, which I think is not bad at all. Not bad at all. But yeah, definitely you can see from the stats and the leaderboard, like 2,000 people have solved it already because, like, yeah, they're pros at this. They know how to do this. Okay. All right. Yeah, I think this is probably fine. Like, the code is all perfectly readable. What I'm curious about is how can I make this run faster? I'm not sure how to make it run faster. My brain is not working well enough to finish continuing on this. I'm probably just going to call it here. Let's go ahead and just format this and call it a day. Okay, let's see what I've staged. Well, it looks good. Okay, so this was just literally apply the perfectly vanilla A-star algorithm. So people who pre-wrote that or had done A-star recently had an advantage. I didn't today. It happens. Okay. Add day 15 solution. All right, that will be available on github.com/LizTheGray/adventofcode if you want to check that out. And otherwise, I think I am probably going to call it there. So let's go ahead and raid someone else. How about Irene's? See you all over there. Cheers.